Dear students, today we start our microprocessor assembly language. The last chapters or last unit is the introductions to advanced microprocessor. So this in advanced microprocessor we discuss about the 8086. We already discussed about the 8085 and its architectures, registers, flag registers and etc. Also we study about the different instructions and different programming, how to write the programming and read the now in this last session we discuss about the 6.1 in the topic as per your syllabus is a block diagram of 8086 architecture. Then 6.2 is the register organizations and flag register similar as the 8085. Then 6.3 is the concept of instruction pipeline. Then memory segmentations and its address generation. And last topic is the maximum and minimum mode of operation. So these 6 topics will remain in our syllabus to complete our chapters of unit 6 of introduction to advanced microprocessor. Now before we start this advanced microprocessor or 8086, we have to require some features of 8086 and the comparison between the 8085. So in this session we discuss about only the 6.1 block diagram of 8086 architecture. So let's start with the 8086 features. So now features of 8086 we have discussed about that is the enhanced version of 8085 and is designed by the Intel in 1976. So it has 16-bit microprocessor. So remember this thing. This will be help in the comparison of 8085. Also it has 20 address lines and 16 data line, and so it's provide up to 1 MB storage. So this is its features regarding the database. So it consists of powerful instruction set. It has powerful instruction set. What happened? Which provide operation like multiplications and division easily. Next is feature is it supports 2 mode of operation. One is the maximum mode, another one is the minimum mode. So maximum mode it means it's suitable for system having multiple processor, and the minimum mode means it's have a single processor. Also it's a feature has the most prominent features of microprocessor of 8086 is it has instruction queue. So this is different from 8085. You must have to understood in the next lecture for the instruction queue, which is capable of storing 6 instruction byte from memory resulting in faster processing. So we need the faster processing. This is our requirement. That's why the modification is done in 8085. In 8086 is the faster processing. So it has the first 16-bit processor having a 16-bit ALU, ALU and the 16-bit registers, internal data bus, external data bus resulting in faster processing. Also it has a 2-stage of pipeline. So this is also the new thing in a 8086 which is not available in 8085. One is the instruction queue, another is the pipelining. So pipelining in we study about that fetch stage, execute stage and which improve performance, which will be discussed also in later on. So fetch stage means prefetch up the 6 bytes of instruction and store them in the queue. So this will also we discuss in detail working of fetching, decoding and executing these 3 main our process or working of microprocessor. And execute means the execute this instruction which will be fetched by the processor. It has 256 vector interrupt. So there is also the one advantage of interrupt is the 256, and it consists of more number of transistors regarding with respect to 8085. So these are the features of our 8086 compared to 8085. Now our next topic is the comparison between 8085 and 8086 microprocessor. We already studied the 8085. With respect to this knowledge, we have to compare the different category with the 8086. Now first is the size. Now in 8085 we study it is a 8-bit microprocessor. Here is the 16-bit microprocessor. So remember in terms of size is 16-bit. Then second one is the address bus. In 8085 16-bit address bus, while 8086 has a 20-bit address bus. Then memory. The memory of 8085 is up to 64 KB, where here is the 1 MB of memory capacity. Then instruction. So 8085 does not have any instruction queue. Here is the additional feature is instruction queue. Then pipeline, also the 8085 doesn't support a pipeline architecture, while 8086 support a pipeline architecture. We will discuss in detail pipelining process. Also we discuss instruction queue in a detail in later on. And input output, here is the address is a 8-bit microprocessor, then 2 raised to 8 means 256 input outputs, and here is the 65 or 64 KB input output. So this is also the difference between 8086 and 8085. And also in terms of cost, 8085 is the lower and the 8086 is the higher in the costing. So this is the comparison that you have to remember in 8085 and 8086. Now let's start with our first topic is architectures of 8086. Same way 8085, but some modification is there in 8086 is here. This is our 8086. This will be divided in two parts. It's a BIU and EU. So these two parts will divided, and these all the functional individual parts we have to study. So 8086 is the CPU is divided into two functional parts. Bus interface unit, it means this BIU. So this portion, dotted portion or upper portion, and then next is the execution unit in a lower portion. So we will discuss about each and every section in a separately. Here is the instructional byte or instructional queue which will new for you, and here is the our segment registers. Here is the general purpose registers and the pointers and instruction registers. Here is the ALU, and this is the flag registers, and this is the control all the this. So memory will be interface this way. So this will discuss in a working portion in a later on also. So here we only discuss about the architectures of 8086 in a or block diagram of 8086 in a two parts. So first part is the bus interface unit and second part is the execution unit. So start with the bus interface unit. In bus interface unit is responsible for all types of interfacing with external environment. It means input output devices or memory section will be interface or responsible for all type of interfacing. So BIU perform all bus operations such as instruction fetching, then reading, then writing operand from memory, and calculate address of the memory operands. So you also very clearly know about the operand and calculating how the memory. Then also the instruction bytes are transferred to the instruction queue. So these instruction bytes are transferred in instruction queue. Then BIU, it means bus interface unit. There are so many functional group. There are in a different parts. One is the instruction queue, then next one is the segment register, then instruction pointer. So we will discuss one by one instruction queue, segment registers and instruction pointer. First one is instruction queue. What is the instruction queue? So this queue permits prefetch of up to 6 byte of instruction code. Instruction codes of 6 byte will be permitted or prefetch while current instruction execute. Next instruction is a fetch is called instruction pipeline. This will also be discussed in a pipeline section. But what the meaning of that instruction queue? The instruction queue firstly permit the prefetch. It means in a previously we fetch the data in terms of 6 byte in instruction code while current instruction is execute. So current instruction is execute, but fetching data will be available for the next instruction. From this call is the instruction pipeline. Then this is shown in a figure. So this is our first operation. Just processor first fetch, then decode and execute. So this in first cycle, this will fetch the data at that time. Before complete the fetch and then transfer to decode, at that time the second operation will start the fetch the next instruction and then decode. At that time this will be decode to execute. So this will fetch, decode and execute. This is our three main operation. But when fetching is completed and decoding is start from the first cycle, at that time second cycle will be parallel start. This is fetch, and then after second instruction fetch is completed and decoding start, at that time first cycle or first instruction execution is start. At that time same way the fetch is completed of second cycle. The fetch is start and then decode and then execute and then this is execute. So this cycle processor, it means parallel working is done. It's called pipelining processing. This will discuss very in a later on soon. Now second is the segment register. So there are 4 16-bit segment registers are there in a BIU. First is extra segment, it's called ES. So remember this ES. Then after code segment CS, then after data segment DS, and then after stack segment SS. So these segment registers are used to hold 16-bit of starting address, 16-bit of starting address of each of the segments. So this one is, remember, starting address 16-bit of segment. And then instruction pointer IP. So this instruction pointer IP holds the 16-bit address of the next code within the code segment. So this is the portion of BIU. Now we discuss about the execution unit. The execution unit tells the BIU where to fetch instruction. Remember this thing, the work of execution unit is tells the BIU. So EIU is tells the BIU where to fetch instruction or data from. So it decode the instruction and execute the instruction. So this is the main function of execution unit. So decoder in the execution unit translate the instruction fetch from memory. So which the data will be fetched from the memory, this will be translate and generate the different internal external control signal by using the control portion and require performing the operation. So this is the first part of working. Then after function of ALU. So this EU has a 16-bit ALU which perform the, as we know, arithmetic operation such as adding, subtracting, or logical operations like AND or XOR or increment, decrement, etc. will be function done by this ALU. And next portion is the flag register. Now same in 8085 flag register, but here is the flag register is a 16-bit is a flip-flop which indicates some condition produced by execution of instruction or control certain operations of the EU. They are modified automatically by CPU after mathematical operation which will done by this ALU. So it has total 9 flags. So this is difference between 8085 and 8086 flag register. We will discuss flag register in detail in the next video lecture. And the last portion is the general purpose register. So EU has 8 general purpose registers. Is the label as AH, AL, BH, BL in a pair, CH, CL in a pair, DH and DL in a pair. This register can be used individually also and for the temporary registers of 8-bit, and together it will be used as a 16-bit, 8 plus 8, 8 plus 8, similar like that. The AL register is also called as accumulator. Okay, so remember this thing. Then after stack point register, the stack point register SP contain the 16-bit offset from the start of the segment of memory locations where a word was mostly recently stored in on the stack. Okay. So and other is the pointer and index registers. So EU has also contain a 16-bit SI, it means source index, and a base pointer BP registers, and DI it means destination registers. These 3 registers can mainly use for temporary storage of 16-bit data, just like a general purpose registers. So dear students, I think you have understood about the block diagram and all the of 8086. So thank you very much. We will be discuss more in a next video from 6.2 and onwards. Okay, thank you.